Welcome back. Okay, so now we're going to talk about the other forms of graphing quadratics. The first form we'll look at is graphing in vertex form. Now, this is the form you should be familiar with from when you first dealt with parent functions. It's the form that's in y equals a times x minus h squared plus k, where h is your horizontal shift and k is your vertical shift, and a is your vertical stretch and vertical compression, and when a is negative, it reflects over x. So, one thing I want to point out here that we really haven't spoken about before is that the axis of symmetry when it's in vertex form, if we can see here, our axis of symmetry is going to go through the center of, or the vertex rather, of the parabola. And it would look rather like this. So it's just going to kind of go through like this. And as you can see, it's going to be a vertical line. And any vertical line starts with x equals. And in this case, it's going to be x equals h, where h is your horizontal shift. So if h is 3, then it's going to be x equals 3 as your equation for your axis of symmetry. So let's kind of practice how we're going to graph these. And when graphing in vertex form, just like standard form, we need a total of 5 points, one of which includes the vertex. So let's start with the vertex. That's always a really good place to start when you're graphing any curve, is to deal with the vertex. So the first step, we're going to graph our vertex. And so recall that the parent function is at 0, 0. And so since we have a minus 3 here, it's going to be a shift to the right, 3. And then the minus 5 indicates it's going to be a shift down 5. So let's go ahead and put our vertex down. So right 3 and down 5. 1, 2, 3, 4, 5. And there's our vertex. Yay! We got a start of a parabola. The next, I do want to point out that the vertex, the coordinates of the vertex are always going to be h, k. Okay, remember, this is minus h, so we're just looking at h. The sign hasn't changed. Okay, this one is plus k. So the sign changed from a plus to a minus. That means a negative 5 went into here. So that's down 5 and right 3. It must have been a positive 3 because the sign didn't change from the minus h. So hence, our vertex is always going to be located at hk. I also know that this vertex is going to be a minimum because we have a positive a value of 1/2. It's going to open up. So thus the vertex has to be a minimum. Okay, so step 2, we're going to get our, other points. We're going to substitute to get our other points. That's a terrible H, points. Okay, so here's my X, here's my Y. So we're going to take the same approach we did with standard form. We're going to pick a couple points to the left, and then we're going to reflect them on the other side. So this doesn't have a C value, so we don't know what the y-intercept is. So we actually are going to have to just plug these in and work it out. So let's start off. I'm going to start one point to the left of our vertex. So I'll go with 2. And so when x is 2, and then I don't want to necessarily always get the next point over. It's good to see if you can kind of maybe skip one and then go over, then choose that one. But you don't want to go too far over because your value is going to get either too big or too small. So I'm not going to go with 1. I'm just going to skip 1 and try 0. So those are the 2 points I'll try for x. So let's go ahead and work those out. Let's see, y equals 1/2, and then x we said is 2 minus 3 squared minus 5. Okay, let me get a little bit more space to work with. So y equals 1/2, and that's going to be -1 squared minus 5. Y equals, okay, so -1 squared is +1, and 1/2 of 1 is, well, just 1/2 minus 5, and thus y is equal to -4.5. So 2, when we use 2, our y is going to be 4.5. Now we'll do 0. So y is equal to 1/2 0 minus 3 squared minus 5. So y is equal to 1/2 of -3 squared minus 5. Okay, so we square 3. That's going to give us a +9 minus 5. 1/2 of 9 is 4.5 minus 5. Thus, y is equal to -0.5. So we'll get -0.5. And this is a -4.5. Let me get my negative in there. Okay, now we have 2 points on one side of our vertex. And recall that the axis of symmetry does go through this vertex. So just to help you see, our axis of symmetry is going to be here, where x equals h is the equation, and h being 3, so x equals 3 is the equation of that line. I'll just jot that down. X equals 3. That's the axis of symmetry. Okay, now so let's do this. 2 and -4.5. So 1, 2, 3, 4, and then 0.5. So halfway between -4 and -5 will be that point. And then 0 and -0.5. So that's just going to be right here. That's going to be our y-intercept, -0.5. And now we're going to reflect. So this is, I guess you could say, is our third step. We would reflect. Okay, so this is 1 unit from here to here. So we're going to go 1 unit in the other direction. And this one is 3 units. This point is 3 units from our axis of symmetry. And see, it helps to draw the axis of symmetry, so you can see, how far you have to reflect it. And so that means we need to go 3 units, 1, 2, 3, in this direction. And we can plot this point. And then, let's see, we connect them. And it's just going to kind of curve up like so. Oops. Okay, that was terrible. It's going to curve up like so. And as always, don't forget your arrows. Okay. And then this one's going to curve up like so. try to hit the points. Really hard to do this on this writing pad. Okay, so we have our parabola. We did it with 5 points, and we've shown our work. So please, please, please show your work. That's how you can justify your answers. And if you don't get it right, that's how you can get partial credits. Okay, so all this messy stuff is good. Don't make it too messy, though. It's got to be readable. This brings us to our last form, graph intercept form. Y equals a times x minus p, x minus q. What? I haven't seen this before. Okay, so this is new. Characteristics of the graph in intercept form includes that, well, you need to know what the intercepts are, specifically the x-intercepts. So, if I look at this intercept here, we give it the coordinate p0, and this one is going to have the coordinate q0. So where p is where it crosses on the x-axis on the left, q is where it crosses the x-axis on the right. So, so that's where the p and the q come in on this equation. Okay, those are going to be. And one thing I want to point out is that there are minus signs. Okay, so these work like the minus H in vertex form. Things are going to be opposite of what you might think they are. The sign change, you have to be aware of that. Also, I want to point out that your axis of symmetry is going to go through your vertex. So right there, and the axis of symmetry, recall, cuts the parabola in half. It makes it symmetrical on the left and the right. So naturally, if it's right in the center, it's going to be equidistant from P to Q, right in the middle. That's what equidistant means, right? So how do we find that? Well, we just have to figure out the halfway distance between P and Q. And how do you find the halfway distance between, 2 points? You're going to take an average, right? You average it out. So you could say P plus Q and divide that by 2. Hence why we get this equation of x equals P plus Q divided by 2 to get your axis of symmetry. Okay? You don't have to memorize it. You just reason it out. It's halfway between P and Q. So find the average, the mean, and you got it. Okay, so, and of course, we have an A value in front, and again, that works just like the A's in the other ones. It's your vertical stretch, your vertical shrink. If it's negative, it's reflected, so all that's the same. Okay, let's graph one. So we're going to graph y equals 2, and then x minus 4, and then x plus 1. Okay, this is the only, of the three, this is the only one I'm going to not ask 5 points, but instead I'm going to ask you to graph just 3 points, and I'll be happy with that. Those 3 points include the intercepts and the third point being the vertex. So with this, we don't start, well, I don't want to start with the vertex, I want to start with the intercepts. So first we're going to graph x-intercepts. Okay, so that means we need to know our P and we need to know what our Q is. Remember, it's a minus P and a minus Q in the equation. Okay, in the general equation, it's supposed to be minus P and minus Q. So because in this first one it's just minus 4, then the sign didn't change. That means our P value is in fact going to be 4. And our Q value is, if we look here, oh, wait, that's a plus 1, but it's originally minus Q. Well, how do you get a minus sign and make it plus? That means you put in a negative. Okay, that means that, this is in fact a negative 1 where we had a subtraction sign originally in front of it, so that made it plus. So, with that logic, we can say, oh, well, Q is in fact negative 1. Okay, so knowing that our coordinates are going to be 0, 4, and 0, negative 1, that's going to be our x-intercepts. So 0, negative 1 will put us right here, and 0, 4. 1, 2, 3, 4. Okay, next we're going to find the vertex. To do the vertex, we have to find the axis of symmetry first. Okay, so I guess we could say a subset. We need to find axis of symmetry. Okay, so we could actually make that our second step. Find the axis of symmetry, and then we're going to find the vertex off that. So the axis of symmetry is right in the middle. It's between those 2 points. Now, these are 2 whole numbers. It's not necessarily always going to be 2 whole numbers, or integers, rather. And you want to use the formula. Well, it's the average of the 2. So it's x equals, remember it's a vertical line, p plus q. So p plus q divided by 2. So p, which is 4, plus negative 1 divided by 2. So 4 plus negative 1 is 3, and then divide that by 2, so it's going to be 3 halves, or 1.5 is going to be the equation of that. Okay, so we're going to have to find 1.5. Actually, let me find that on the x-axis. So that's going to be 1 and then halfway between right here. So let me kind of draw that in. So here's my axis of symmetry, halfway between 1 and 2. Now our vertex is on here somewhere. Now I know this vertex is going to be a minimum because the a value is 2. It's positive, so it's opening up. Thus the vertex is a minimum. And it's got to be somewhere on this axis of symmetry. Where? Well, we figure it out by taking that x value for the axis of symmetry, because they have the axis of symmetry and the vertex have the same x, and we substitute x into the equation and find y, and that's the other coordinate we need for other part of the coordinate we need in order to get our point. So let's do that. Let me give myself a little bit more room to work with, so I'm going to scroll down here. All right, so it's y equals 2 times 1.5 minus 4 times 1.5 plus 1. All right, so 2, and then this is going to give us negative 2.5, and this is going to give me positive 2.5. All right. And now we just multiply this whole mess together. Okay, so that's going to get me negative 12.5. Okay, so we will substitute, so my point is that my vertex is at 1.5, negative 12.5. Okay, so that's my graph isn't quite big enough for that. So that point's going to be actually beyond my graph. I'll just put it right here. Let me highlight that point. So that's my point right there. It's 1.5. I'm just doing that so you can negative 12.5. Okay, doing that so you can see it. All right, so now I'm going to connect my 3 points and get my parabola. So it should look like this. It's just going to kind of curve up. Oh, wow, that's really not good at all. And yeah, that's the opposite of good too. That's like anything but good. That is really hard for me to do on here. Okay, so anyway, hopefully you'll do a much better job than I can do with what I have. Let's get away from the graphing and let's take a look at something that's just more algebraic. So we're going to write an equation that's in, well, what form is this in? Hopefully you're thinking or saying or screaming out loud, intercept form. And one of the things we want to be able to do is convert between the different forms. So converting between this form, intercept form, into standard form is pretty easy. We're calling that standard form is y equals ax squared plus bx plus c. So all you have to do is just multiply this mess together. So y equals, so I'm going to distribute to 3x minus 12, and x plus 6. Now you have a binomial here, binomial meaning two monomials, 3x and minus 12, or 3x and 12 be the monomials, and then x and 6 are the monomials for the binomial on the right. So how do we do that? The way I want you to view it, kind of used to viewing it, is we take the first term and distribute it to both terms in the second binomial. So we have y equals 3x squared plus 18x. And then we take the negative 12 and then we distribute that to both terms. So negative 12x, and let's see, it's going to give me 72, negative 72. So now we just simplify. So you just distribute, think of it as distributing the first term to both terms and the second term to both terms on the second binomial. So 3x squared plus 6x minus 72. So now it's in that form of standard form, y equals ax squared plus bx plus c. Okay. You also will need to be able to convert from vertex form into standard form. So really it's, fairly similar. Just got a couple of extra steps here. Okay, so first off, I'm going to say, well, what we're saying here is we got y equals negative 2, and then here we have x plus 8. Okay, the squared here does not distribute. Exponents do not distribute. Let me say that again. Exponents do not distribute. Now, I want you to write that down. Exponents do not distribute. I emphasize that because every year people distribute exponents. And it's a tragedy because it leads to wrong answers. And so what's going on here is you're saying x plus 8 squared. Well, if you know x squared is x times x plus 8 squared is simply x plus 8 times x plus 8, and then plus 35. So, with that being said, we're going to now just work this out. I'm going to distribute the -2, so negative 2x minus 16 times x plus 8 and then plus 35. Now we will multiply the binomials together. So bring it down, y equals, and we'll distribute the negative 2x to both terms, leaving us with negative 2x squared minus 16x. And now we'll distribute the minus or negative 16 to both terms here, minus 16x, and that should be negative 128 plus 35. Okay, so now we'll just combine our like terms, and we'll have y equals negative 2x squared minus 32x minus 93. And that is in standard form. Ax squared plus bx plus c. And we box that in, more or less. So that's graphing quadratics in both vertex and intercept forms, and then converting both of those forms into standard form. And that's it. I'll see you on the flip side.